This is Euclid Book 10, proposition number 108, and I bet you'll be thrilled when this book is over with. I know I will. Okay. We have 8 more proofs to do. If from a rational area a medial area is subtracted, the side of the remaining area becomes one of 2 irrational straight lines, either an apotome or a minor straight line. From the rational area BC, alright, so where is BC? Well, this area right here is BC. It's this plus this here, okay? Let the medial area BD, which is this area right across here, be subtracted. We're going to actually subtract this from this whole area, okay? I say that the side of the remainder EC, which is this right across here, I say that this side becomes one of 2 irrational straight lines, either an apotome or a minor straight line. Okay? Now then, what we're going to do here is we're going to make this area, all right, and when we remake this area, that's right, we're going to remake it into a different shape. You're going to see that in just a second. We're going to remake this area into a different shape. And when we do, one of the sides of the remade shaped areas is actually going to be either an apotome or a minor straight line. That's what they're trying to do here. For let a rational straight line FG be set out. Okay, so we're going to make this line right here. To FG, let there be applied the rectangular parallelogram GH, which is equal to BC. Okay. What is GH? That's this area plus this together. All of this is going to equal the entire area inside of this great big box. Okay. And let GK equal to DB. Okay, so now we have GK, which is this area right here. It's going to equal this area right here. And we're going to subtract this little area from the entire unit here. Okay? So we've got this whole thing. We're going to subtract this area from all of it. Therefore, the remainder EC, which is this right here, is going to be equal to LH, which is this area right here. Okay. Since then, BC is rational. Okay, so this whole area here is rational. And BD is medial. That's this little tiny area right here. That's medial. While BC is equal to GH, this area right here is going to be equal to all of this. And BD is equal to GK, which is this. Therefore, GH is rational. This whole area is rational. And GK is medial. This area here is medial. And they are applied to the rational straight line FG. This whole area and this whole area is going to be applied to FG. Therefore, FH is rational. So the line FH here is rational. And it's commensurable with FG. Okay, so this whole line is commensurable with this. That's by Euclid Book 10, proposition number 20. While FK is rational, this line here is rational, but it's incommensurable with FG. This line is incommensurable with this. And that's by Euclid Book 10, proposition number 22. Therefore, FH is incommensurable in length with FK. So, FH is incommensurable with FK. That's by Euclid Book 10, proposition number 13. Therefore, FH and FK are rational straight lines. They're only commensurable in square. Therefore, KH is a first apotome. Well, actually, it's an apotome, okay? And that's by Euclid Book 10, proposition number 73. And we've got KF annexed to KH. Now, the square on HF, which is this, is going to be greater than the square on FK, which is this, by the square on a straight line either commensurable with HF or not commensurable. First, let the square on it be greater by the square on a straight line commensurable with it. Now the whole HF is commensurable in length with the rational straight line FG set out. Okay? So this whole line here is commensurable with this line right here. Therefore, KH is a first apotome. That's by Euclid Book 10, third set of definitions, number 1. But the side of the rectangle contained by a rational straight line and a first apotome is an apotome. Okay. We're going to make a rectangle, and we have to contain it by a rational straight line and a first apotome. We know that this is a rational straight line. That's this right here. So two sides of this rectangle are going to be the length of FG. We also know that KH here is the first apotome. So the other two lines are going to be the length of KH. So when we describe the side of the rectangle contained by a rational straight line and a first apotome as an apotome, we're describing this. Two sides FG, which is a rational straight line, two sides KH, which is the first apotome. And that's by Euclid Book 10, proposition number 91. Now we know that this line is a first apotome. Therefore, we also know that this line is an apotome in itself. Therefore, the side of LH, well, what is the side of LH? Well, it's this right here. It's LK. Well, isn't the length of LK equal to the length of FG? Didn't we already establish that FG is an apotome? Well, therefore, LK is also an apotome. Okay. Therefore, the side of LH, that is, since this area is the same area as this, then the side of this, if reshaped, would be an apotome. But if the square on HF, which is this whole line right across here, if the square on HF is greater than the square on FK, if this is bigger than this, by a square on a straight line which is incommensurable with HF, that while the whole FH is commensurable in length with the rational straight line FG set out, then we're going to say that instead of KH being a first apotome, we're going to then say that KH is a fourth apotome. So we change the first, right across here, to F-O-U-R-T-H. Now we're going to change it to a fourth apotome. This is by Euclid Book 10, third set of definitions, number 4. But the side of the rectangle contained by a rational straight line and a fourth apotome is a minor. That's by Euclid Book 10, proposition number 94. Therefore, this LK being identical in length with FG here, LK is identical in length to FG, therefore LK is a minor. And that is the whole proof. Alright, I will tell you more in a future video, so I want you to stay tuned.